And when you go a little bit beyond just making simple yes and no association, so for example, like if you think about the light and me throwing it, it's a very simple yes or no. So yes, the light goes on, and then there's a ball is thrown. Uh, so one step further than that is, instead of like just a light bulb lighting up, then it might be the intensity of the light. And so then you start to use quantitative data. So there could be a light here that is slowly going up, and when it reaches a certain brightness, then I throw it. And then you can't, at this point, you can't just say when the light is on, then a ball will be thrown at me. You have to start talking more quantitatively, and then you might say when the light is at this level of brightness, then the ball is thrown. And so, if you want to be more precise, then you have to develop a language that is more accurate than very bright or a little bright. So then you start using a word which will talk about the brightness. You invent a word because it is useful. There's a requirement to develop a word associated with the concept brightness, and then you start using lumens, for example, and you say at 300 lumens, well, this happens. And so you realize that at some point you have a qualitative idea where you use a word you invent, let's say brightness, to talk about something specific that you can quantify, and then you can relate to other stuff. But you realize that you also have to talk about it quantitatively in some cases. And then what happens is that you could have two things that you might want to compare. One is quantitative, and the other might also be quantitative. So instead of at this level of brightness, then the ball is thrown, you could say at this level of brightness, then the ball is thrown with an X amount of force. So I could say when the light goes on at the specific brightness, then there's a correlation. If it's very bright, then the ball will be thrown very hard. If the light is very dim, then it will be thrown softly. And so you start making links between things that are all quantitative, and then that's when you start to have some mathematics that are a little bit more accurate and which describe the relation of things. And this is where the fun really is, in my opinion, because you're going to make like binary connection all the time. You're going to be like, hey, when my cat is hungry, then he starts meowing to me. It's very simple. Like if this, then that, and then I can feed him some food. But when you get into just being curious about random stuff and how they correlate to each other, you're having fun. So I could give you like a very simple example. You could say, I'm interested to see if I put water in the pan and I blast it like at high heat, how much it's going to take before it starts boiling. And then what you can be interested in is to see if I put just like 100 milliliters of water, how long is that going to take to boil? And then you try it, and then you see that it takes X amount of time. And then you say, how long is that going to take if I put 200 milliliters? And you test it. And so there already is a formula that exists in physics that will describe the relation of heat and how much water and the time to boil. It already exists, and you could like just look it up on the internet or in a physics book or whatever, and you'd have your answer. But you miss all the fun of like discovering it yourself, and you're probably not going to have as good as accurate a description of the relationship as the full physics analysis of it. But you're gonna be close, and you're gonna have a lot of fun. You're gonna be able to create their relationship, and then you could have an equation, very simple equation that corresponds to time it took to how much water there was. And it might not be like a really appealing experience to you. Maybe you're not really interested in that kind of stuff, but there might be other things that you're interested in, which you previously just looked up on the internet. What's the relation or whatever, or how does this work? And instead, you could have just tried it yourself and make mistakes and learn. And I wish that there was an interest to make mistakes, but at least you're learning through experimenting yourself. And I really think that those people who make the effort to discover these things by themselves and make experimentation and try to see if there's a correlation between this and that, and just exploring things, you're gonna get really, really good at thinking for yourself and noticing what is true, what is not, what works, what doesn't, because you're always relying on your own tests and your own habit of linking things together. And when you get excited by this, you're gonna start wanting to explain things that are more and more complex, and you're going to realize that you need a new vocabulary. You're going to realize that what you want to describe or want to understand, you need some new material. You don't have the tools to do it, and then when you search for it, you're going to find like physicists or mathematicians or chemists or biologists or whatever who came up with these tools, and you can learn about them. So, and then when you learn about them, you're not just learning them for the sake of remembering these rules. You learn them because you're excited to apply these afterwards. And yeah, so when you start, there's really a point where you start just looking at the world and being curious about how this relates to this, and you start using logic. You make deductions, you make inductive reasoning. You say, hey, what happens if I do this? And then you repeat it, and you realize that when you do something repeatedly, you always get the same result. And then you realize that, hey, there's something there. There's my hypothesis might be good. I think there's a correlation there. Just doing that by yourself will set you off, I think, on a really, really awesome adventure. And I think afterwards, if you meet other people who are doing that as well, then you don't need to resort to whatever other people are thinking to have a discussion. You can discuss with people who have done their own experiments, and they tell you about it, and you can talk to them about your own experiments and compare and collaborate. And I think that if you get busy with these kinds of exchange with people, you're gonna have an awesome social life. I mean, it's weird because you're sort of solving the problem of sometimes politically there's a lot of clashes, and I mean it's so awesome to just talk about our own experience and our own tests, and it diverts you from talking about things that are not really important, I think, which create a lot of tension between people. And just like, hey, I mean, I don't know, if you really focus on the things you're excited about that makes you happy to be in this world and that are intriguing you, then everyone's just happy to talk about things all the time, and I think things go smoothly. And maybe it's okay if you didn't discover anything new, because in the end you're having fun. You're rediscovering things that people have already discovered, And that's totally fine because you're having a good time and you're not doing destructive things. You're just creating and inquiring about how things work and exchanging with people in a positive way. Um, so yeah, I really think that there is something there for people to discover things, and I'm citing Noam Chomsky on this. Um, you 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 want to discover yourself through discovering the world, and I think that's a really interesting uh, approach to understanding yourself, which is to inquire about the world and try to make sense of it and try to see links as a way to understand how you work, how your brain works, how you're trying to uh, group things together and try to organize what you know and categorize things and being efficient with if this happens and this happens, it's the same mechanism, and then you can describe two things with just one concept. And, uh, so it's you discover that making links between things is a way for your brain to be efficient by reusing information you've already discovered. And you can see how being efficient memory wise leads you to try to see a link between things. Having one theory or one equation that explains a lot of different things, this is very efficient. Um, so yeah, I just hope that this is inspiring to people to like do their own experiments and try to see the world and not be afraid to make like dumb hypothesis about things that seem obvious, and you say probably like there's someone who has already discovered this. It's fine, like try it yourself. I think very quickly you can start being interested in new stuff that will be useful for others. So yeah, I hope this is inspiring.